Welcome to Coventry Lord Mayor's Peace Lecture 2020, which is coming to you from Coventry, the UK's only city of peace and reconciliation. I am Philip Brown, Chair of the Lord Mayor's Committee for Peace and Reconciliation. We organise the Lord Mayor's Peace Lecture every year on or near the anniversary of the night Coventry suffered its most severe bombing attack during the Second World War. This year is the 80th anniversary. And this year, the lecture is being delivered in the face of two major global emergencies. The most obvious is the global pandemic. The second emergency, which some people would argue presents a greater danger than COVID, is global warming. That will be the subject of tonight's lecture by Professor Sir David King. We invite you to send questions for Sir David. If you are watching this via the webinar, you can use the Q&A box. Click on the link at the foot of your screen. This lecture is being hosted by the Rising Global Peace Forum, which we thank for organising this video broadcast and providing all the technical support. A recording will later be placed on our website, coventrycityofpeace.uk. Now I hand over to our Lord Mayor, Councillor Anne Lucas, who will introduce our distinguished speaker.
Honoured guests, ladies and gentlemen, good evening. Welcome to a highlight of our annual Peace Festival, the Lord Mayor's Peace Lecture. We've been honoured to feature some truly inspirational speakers over the years who have delivered thought-provoking and challenging lectures, and I'm very much looking forward to tonight's event. It is a topic close to our heart here in Coventry and one that is guiding our current work as we change and develop for the future, the issue of climate change. And there can be few better qualified to speak on that subject than our guest tonight, Professor Sir David King. Sir David was Chief Scientific Advisor to Prime Ministers Tony Blair and Gordon Brown. He also served as the Permanent Special Representative for Climate Change under David Cameron and Theresa May. In those roles, he was a challenging voice on the subject of climate change and described it as the greatest challenge facing Britain in the world in the 21st century. Sir David has received many honours over the years, including 22 honorary degrees from universities around the world, a fellowship of the Royal Society, and an officier of the French Légion d'honneur. Thank you for being with us tonight, Sir David. It's an honour to welcome you to our Peace Festival. The issue of climate change is very much in our thoughts in Coventry. We are developing electric vehicles and batteries. We're pioneering on-street chargers. We're narrowing roads and promoting green travel. But we know we must do more. And maybe these new difficult times can inspire us to do that. In recent months, people around the world have joined forces to face the common threat of COVID-19, and we've changed the way we live. We know the danger there is, and we have acted to keep ourselves safe from that danger. However, many scientists would argue that climate change is a much greater threat and one which will have far more devastating consequences if not tackled with equal urgency. So tonight's lecture promises to be both enlightening and challenging and comes at a very important time for us all. Ladies and gentlemen, the Lord Mayor's Peace Lecture is now in its 36th year and has seen our city welcome leading figures who inspire us to change the way we think and act. Today's lecture is very different to those we're used to as we keep each other safe and support our frontline workers in the fight against COVID. So thank you all for joining us in this new virtual world. It is a shame that we cannot greet you all personally in our beautiful cathedral, itself a sign of hope and man's ability to overcome adversity and build a better world. This month, we mark 80 years since the Blitz that devastated our city, destroyed our old cathedral, and created the ruins we see today. The night of 14th of November, 1940 also saw the birth of our city as a beacon for peace. In those 80 years, we have reached out to others overseas and here at home. We have become a city of peace and reconciliation and a city of sanctuary. And we've grown into a beautiful multicultural city. We have achieved so much, but we know our work isn't done. There is still suffering and inequality in our world. And sadly, 75 years after the Second World War, there is still conflict and aggression. There are still people losing loved ones, people forced to flee their homes, and people being persecuted and oppressed. That's why we must continue to take inspiration from those who endured that terrible night and emerged with a message of peace and forgiveness. And that's why we continue to tell our story. I've always been very proud of our city's work for peace, but being Lord Mayor gives you an even closer look at that work, the people behind it, and the effect it has on others around the world. And it really is very moving. Tonight, it will be inspirational to hear how we can further our work to help others and how our actions here at home can bring about change in the world. Enjoy the evening, everyone, and my very best wishes for the future. It is now my honour to introduce Professor Sir David King. Sir David.
Lord Mayor, thank you so much for that wonderful introduction. And let me say what an honour it is to be invited to deliver this very important lecture in the world's calendar of lectures dealing with the subject of peace. Peace, stability, and well-being for all. This is our aspiration. But let me say, none of this will be possible if we, as humanity, don't quickly repair our damaged climate system and learn to live both with and as part of nature, that is, with the ecosystems that we depend on to manage a safe future. I'm going to give a brief overview of the current state of the climate change challenge, and then I'll provide a clear strategy for the way forward. So I hope that you'll see that while the initial part of my talk is rather challenging to sit and listen to, as it transpires in the strategy for hope, there is a way forward. And all I'm going to say now is, and we will all need to pull our weight in moving that way. If I could have my slide presentation. I'm not going to overdwell on the science, but I feel I have to say something about it because it's quite a venerable science, the science of climate change. By the time we reached 1898, essentially all of the building blocks of current climate science had been developed. First of all, 1820, the great French mathematician Fourier. Then came the Irish scientist Tyndall. And Tyndall's discovery that it wasn't the entire atmosphere that absorbs radiation and keeps us warm like a blanket, but it's only these minority gases, the greenhouse gases, carbon dioxide, water vapor, methane, etc. The Swedish scientist Arrhenius, 1898, was the first to say, wait a minute, we're burning fossil fuels and we're therefore adding greenhouse gases to the atmosphere, which must mean that we will simply have a warmer average temperature on the planet's surface. 1898, this isn't some modern idea. And what he calculated, and this is what we would today call a back-of-the-envelope calculation, no computers then, what he calculated was that if the greenhouse gas content of the atmosphere doubled from 265 parts per million to 550 parts per million or more, then the temperature rise would be about 5 degrees centigrade on average. And although that doesn't sound like an awful lot, it means a massive transformation to all societies. If I could have the next slide, I want to say that actually what Arrhenius was worried about in 1898 has happened. By the way, I may use a few graphs, but if you listen to me and don't want to watch the graph, I think you will be able to follow what I'm saying. So back in 1700, there we are at about 275 parts per million of greenhouse gases in the atmosphere. And because not only were we burning fossil fuels, we were also removing forests around the world to provide the agricultural activity that we deemed we needed. And so by the time we get to 2020, this year, you'll see that we have reached a total of 500 parts per million. And there I'm adding together CO2 and NOx gases, and in particular methane, which means that we're considerably higher than carbon dioxide alone. Methane levels are going up because of the increased demand for meat from livestock, and livestock produces a lot of methane, but also from agricultural practices such as rice production. The increased global population is creating more demand for both. And so we've got a rise in methane as well as carbon dioxide. So there we are. We're already at that rather challenging level. What does modern science say? Well, modern science says, well, Arrhenius got all the equations right, but he left out a number of things. And maybe it won't be 5 degrees, it'll only be 3 degrees. Now, 3 degrees is already a very big challenge. So let me go forward to the next. In the period when I was working with Tony Blair, I set up with the foreign secretaries of that time a large number of climate attaches in our embassies around the world. Britain became the most powerful negotiator in the world on climate change. We had 165 climate attaches. Every ambassador knew this was a priority for Britain. 2008, we had the Climate Change Bill of Parliament, all-party agreement. That was a magnificent thing, the first country in the world to get that, on the need to achieve 80% reduction by 2050. Then we get to 2017 when Theresa May, in the last few weeks of her premiership, announced net zero must be the target for Britain by 2050. So we've seen increasing targets through the years. And that target is delivered through a Climate Change Committee of Parliament. So as we've changed governments, that target has not changed. But except for the better. But what I had to do when I moved into the Foreign Office was, of course, look at the major parts of the world and see how, through bilateral engagement, we could persuade countries like China and India in particular to join the process of managing this challenge. And I produced the world's first climate change risk assessment program, working with the governments of China and India in particular. And this report still sits on the Foreign Office website. It's a seminal report because what we showed was that if you bring in actuaries from the City of London, people who are used to not calculating what is the most probable outcome for a given level of climate change, but what is the single threat that might pose a very big challenge, even though it seemed to have a low probability of happening. That's exactly what these risk assessors do when they work for the reinsurance and insurance sector. And so I said to each of these two governments, after we'd been talking for some 3 months, we had 97 experts put together, working for about 9 months together, was what are the biggest challenges facing you? And the big surprise came back from the Chinese government. What's the risk of rice crop failure throughout China in 1 year? Now, obviously, that's a very big challenge to China. And at the moment, the risk of that happening is rather like the risk of your house burning down. It's very low. But as we move forward in time, just to have a 0.5 degree to 1 degree temperature rise, that risk rises to, first of all, 1% in a given year, to something that is approaching 5%. And as the temperature goes on going up, the risk goes up dramatically. So what we did manage to achieve by working with those two governments was a real understanding of the need to commit to reducing greenhouse gas emissions, and in particular, carbon dioxide emissions from the use of fossil fuels. I could have the next slide. We then came to Paris. So that agreement with those two countries was reached in the run-up. I made 96 official country visits in 2.5 years, so this was quite a busy time. And by the way, I knew before we arrived in Paris, as a result of those bilaterals, that we would get an agreement. So it was no surprise to me that we got an agreement. But that agreement sets a new target of 1.5 degrees centigrade. Very pleased to say Britain was one of the major nations to support the small island states in that target of 1.5 degrees centigrade and no more above the pre-industrial level. We also agreed to a review mechanism on the right there, and that review process is due to be examined this year, 2020, 5 years. And of course, that's been delayed because of COVID-19. The COP26 meeting will be in Glasgow in November, December 2021. And that is where we will review what every country is committing to see if we stay below 1.5 degrees. At the moment, that is not on the cards. Let me just take you to the next slide. And I'm just very pleased that one of the ambassador's colleagues took this photograph and made this slide. Papua New Guinea was the meeting place for the Pacific Island nation heads of government, and because Britain does have possession of a large number of islands all over the world, I was there representing the British government. And this is where I got permission from Number 10 to gun for 1.5 rather than 2 degrees above the pre-industrial level. That 0.5 degree difference makes an enormous difference to the challenges. And I was supporting the islanders who understand that sea level rise will quite simply remove their landmass on which they currently exist. So this is a very big challenge to them. And this was me saying, we too are an island nation, and rising sea levels are the biggest challenge to the British Isles. We will be very heavily challenged if we don't manage to persuade the whole world to go down this route. The next slide. I'm sorry, this is another graph, but all it's saying is that difference between 2 degrees centigrade and 1.5 degrees centigrade is shown here in terms of greenhouse gas emissions, never mind the numbers, on the vertical scale against time 2020 to 2050. And you'll see from this that what this means is that on the 1.5 degrees centigrade objective, we need to get to zero emissions by 2050. And this is the reason why the British government changed its objective to net zero emissions by 2050. It's a tough change, and you'll see the sharp decline in emissions that should take place from this year onwards. At the moment, we are still on that purple curve going up, and there's no sign of us turning down. And that obviously is a real worry. So we are emitting a large amount of greenhouse gas every year today. Next slide. The good news is, due to the fact that the German government, first of all, 1989, introduced feed-in tariffs, which was a major mechanism for subsidies for renewable energies, feed-in tariffs for anyone who was prepared to put solar panels on their rooftop, any company that was prepared to put solar energy into the grid or wind turbine energy into the grid, they would get a very big subsidy at the cost for the cost of electricity. And the net result has been to create a very big marketplace. From Germany came Britain second, 1997. We introduced our policy in Britain for managing to encourage the utilities to switch across to renewable energies with targets every year. And the net result has been a massive increase in the demand for renewable energy sources and a very large fall in price, which is what this graph shows you. Everything from land-based wind to light-emitting diamonds used for light production in our cities, all of these costs have fallen dramatically. The biggest fall not shown here occurred in the last few years in offshore wind, developed here in Britain. Offshore wind, initially at about $150 a kilowatt hour to install, has now fallen to $45 dollars. And what that means is it's competitive with any form of fossil fuel energy to build from scratch. This means that around the whole world this year, 90% of new electricity production is from renewable energy. In other words, the hit that we took in Europe as a result of these feed-in tariffs has meant that the whole world is seeing the market challenge producing a positive benefit for renewable energy. The estimate from the International Energy Agency is that green electricity will be the world's largest electricity power source by 2025. So there's the big positive action that is happening, and it was all initiated before that meeting in 2015 in Paris. So the other thing that I do want to emphasize is that the opportunities, the economic opportunities, the clean air opportunities, and of course the climate change opportunities in the post-fossil fuel era are enormous for innovative technology to be brought into the marketplace by the private sector. The biggest growth sector in the British economy today is the new offshore wind sector, and it's employing about 500,000 people. So what you're seeing is high employment levels, but also very high profit margins for the country as a whole. So what I'm saying about this is that Britain could lead domestically in the advantages that can be obtained from this massive transition that's occurring. Next slide, please. However, only roughly 1/5 of the world's emissions come from electricity production. There's many other sources of emission, the use of oil or gasoline for cars and vehicles on roads, for air traffic, etc. So we needed a massive enterprise, and this is of public expenditure in research and development to develop all the technologies we need in the post-fossil fuel world. This happened on the first day of the COP meeting. You see this picture here, heads of government underneath the banner Mission Innovation. This was quite an exciting moment for me because this was my idea, working with several economists based in London, and I worked hard to see that we could establish. It was willing nations combining to say we will create a fund of about $30 billion a year by 2020, 2021 to spend public money on this research and development program. And the expenditure this year is falling short of that. It's $23 billion. But the difference, the $7 billion difference, is due to one country, the United States, and one president, President Trump, who actually removed the additional $7 billion that should have come from the United States. Nevertheless, the incoming president has made it very, very clear that he will commit himself to this program. We also had a Breakthrough Energy Coalition. These are investors ready to invest money in these new emerging technologies to take them into the marketplace. Bill Gates is the biggest person coming in with a fund of $1 billion. So let me just, you can see the heads of government there. There were 22 heads of government, and we now have 25 governments in this process. The Mission Innovation has a ministerial meeting every year. And I will say something about the future of Mission Innovation in a moment. Can I have the next slide? I'm just showing you here what is my favorite example of a new technology emerging. How do we fly around the world without using any fossil fuels? And how do we do this at scale? Not tiny little airplanes that are very light and able to do this just with solar power. So here's a new model of the old airship, the first way to travel by air. And it's developed by a British company, Varialift Airship. And this airship, as you can see, is enormous. I don't know if you can see, but there's a very large vehicle standing in front of that airship on the ground. And if I tell you, this is an airship that has got an aluminium shroud, and that shroud contains a series of 12 chambers. Each chamber contains an identical range of equipment, and that is, first of all, a large air balloon, a helium cylinder, and a helium pump. If you want this to lift off the ground, you release helium into the cylinders and up it goes, no energy used. If you want to bring it down, you pump the helium back into the cylinder and down it comes. So it's a Varialift. You can hover it at any point and with any weight. This is designed for freight travel. It can take 150 tons of freight, far, far more than any large airplane can do today. And what you see, so the blue area is the hold for the freight. And what you see on the one side there, both sides, of course, is not the standard engine for a jet aircraft. That is an electric engine. This is very large. It's about 170 yards long, about 75 yards wide. There's the advantage. You can cover it with solar panels. When you raise it, fully loaded, you can raise it up to 30,000 feet, at which point you're above cloud cover, which means that you're intercepting a lot of sunlight during the day, and you can convert that sunlight directly into electricity with the solar panels and drive this at a fully loaded at about 300 to 340 kilometers an hour. And that is pretty fast, right? It's not as sluggish as you might think. This is a means of conveying freight around the world is a breakthrough. It's a completely new mechanism for doing this. And I believe it will really, if I can use the phrase, take off in a big way around the world. But of course, the big advantage will also come when it is used for conveying passengers around the world. So this is the kind of future technology that we see developing through mission innovation. Next slide. However, and now comes the big challenge. What is happening, and I'm sure some of you have read about this in our papers, up in the Arctic region, and I will just dwell on the Arctic, but the same is true basically of the Antarctic, but also of the Himalayas, is that ice on those parts of the world, that massive amount of ice that has been building up for 100,000 years plus, has been melting very, very rapidly and with a big positive feedback. In other words, it's melting more and more rapidly with time. So if we go up to the North Pole, the Arctic, in the Arctic summer today, more than 50% of the Arctic Sea is now exposed to sunlight. And what that means is that the whole of the Arctic Circle region is heating up at about 3 times the rate of the rest of the planet. For the whole planet, in terms of the pre-industrial area, we're now about 1.1, 1.2 degrees above that level from the 1700s on average. But if we look at the Arctic Circle region, it's above 3 degrees above the pre-industrial level this summer. And that has been the trend over the last few years. Now, what does that mean? The next slide. Actually, let me move on to the slide after that. This slide, it's a composite, and I've got it all together because it shows what happens when the North Pole is no longer the coldest region in the Arctic Circle region. So the central slide shows the whole planet, and it shows the temperatures, but it also in particular shows the result of a polar vortex, a wind that blows around the North Pole. And that vortex is normally rather circular, but it's been distorted and massively distorted as a result of the North Pole warming up, because the Arctic Sea covers the North Pole region. And because the sea absorbs sunlight very efficiently, whereas the ice that was covering it reflects the sunlight back into space very efficiently. So it's lost that major mechanism for keeping the North Pole very cold. And so when this picture was done by our meteorological office, you'll see that the coldest region of the planet, that purple region, is between Canada and North America and the United States. And I can just tell you, I was in Dallas in 2018 when the temperature in Dallas for the first time ever was freezing, but how cold? It was minus 16 degrees centigrade. And the reason is because of this vortex meandering. And at that point, the temperature in Dallas was actually colder than at the North Pole. So what you have is this complete change in weather patterns, because as that meandering shifts over, you'll see that you'll have a very hot weather and then suddenly followed by very cold. But here are the two big challenges of the heating of the Arctic Circle region. On the left-hand side, the melting, and the melting occurs on ice on land. Now, when ice on sea melts, there's no rise in sea level. But when ice on land melts, it has nowhere else to go but into the ocean. And ice on Greenland has been there for so many years and increasing in volume every year, in amount every year, because of snowfall in the winter. If all of that ice melts, the global sea levels would rise by about 22, 23 feet, by about 7 meters. And of course, every global city in the world will no longer be livable well before that point. I'm going to say, even at a meter, many, many global cities of magnitude, really big cities, will no longer be livable at that point. And I'm going to talk about that in just a moment. The ice on Greenland is now melting, and it looks again as if it's melting faster and faster year on year. That challenge is already there when the temperature rises only 1.1 above the pre-industrial level. I just point that out. This is what we call a tipping point in climate science, where we seem to have passed the tipping point where the Arctic ice melted, and now we're beginning to pass the tipping point where Greenland ice melts. If I repeat again, much the same story in the Himalayas, where 20 to 30% of the ice has already melted, and much the same in the Antarctic region. But the challenge on the right-hand side is one that is peculiar to the North Pole region, to the Arctic Circle region. The Arctic Circle region, land masses, in particular in northern Canada, northern Russia, have a lot of permafrost, and permafrost captures methane. Methane forms a methane hydrate with the water molecules, which becomes unstable below the melting point of ice. So the methane tends to bubble out of the permafrost as the permafrost heats up. And methane, as I've just said, is a serious greenhouse gas. So that is also causing warming. There's enough methane in the Arctic Circle region, particularly in the bottom of the Arctic Sea, that if all of it was to come up into the atmosphere, global temperature rises would be in the region of 10 degrees centigrade, which obviously would be pretty well end game for our civilization. Now, we scientists have been very loath to talk about methane emissions because it didn't seem as if it was increasing dramatically. But I went to the Arctic Circle Forum in 2018, where the Russian Academy of Sciences for the first time sent a group of their scientists to report to us what I'm going to show you on the next slide, which is something that arose from a group of people in a village in the sitting on the permafrost in northern Russia, reporting they'd heard loud explosions. I believe they thought that the Russians were testing weapons in their region, but in fact, the next slide shows you what was actually happening. The large explosions was a sudden release of methane. Methane bubbling up underneath the permafrost actually pushes the permafrost up. And if you are standing on the permafrost and you feel it moving up, you should run like blazes, right? So because the next minute it's going to explode. And what you see here on the right-hand side, on the opposite side of the crater that's been left by the explosion, you see 3 members of the Russian Academy team, and on the opposite side, down in the crater, you see the shadow of the photographer. It's about 50 meters in diameter, about 60 yards in diameter, and about 70 yards deep. How many of these explosions have occurred so far? It's about 1,000. The amount of methane released is not significantly contributing to methane levels today, but of course the worry is that this will continue and grow as we move forward in time. So these are the very big new challenges that we're being faced with. Next slide, please. If we just take the new figures of the rate of melting of ice, and I'm showing you here a picture from just one region of the planet, but I could show you any coastal region of the planet, the Southeast Asia region, and I'm focusing here on Vietnam. What you see is on the left-hand side, the old projection. That projection is a few years old. And on the right-hand side, a projection that's just been published. And you'll see, even on the left-hand side, it's very disturbing because the areas of Vietnam that are flooded frequently, and what you're seeing is a once-a-year flood, are really enormous, and in particular threatening the biggest rice paddy fields in the world in that big delta. You'll see the river splitting down into the delta there, the Mekong Delta. Once that is salinated, it would be very difficult to continue rice growth there. We would have to have developed seawater resistant rice, and that is quite a challenge. But on the right-hand side, these are the new projections. You'll see that essentially South Vietnam and most of North Vietnam underwater at least once a year. From the frequent flooding arises not necessarily from the stable new sea level, but because the sea level rise is only 40 centimeters, but from the fact that in this part of the world they have many typhoons, and these typhoons can cause massive storms to incurse further and further inland. I'm not showing you here Indonesia, but already the Indonesian government is moving and planning the move of their capital, Jakarta, because of frequent flooding of Jakarta to higher land. But of course, Indonesia is an archipelago, and most of Indonesia is underwater. This is just by 2050, in 30 years' time. If we include the whole of that region, Bangladesh, if we look at Indonesia, Malaysia, the estimates of the number of people who will be displaced from their normal place of abode is above 200 million. And of course, that is a massive and dramatic transformation in the ability of the global economy to continue. If we look at the cities under risk, you see here Saigon and Ho Chi Minh City, but big cities such as Mumbai, very seriously at risk quite early on, and all around India, the coastal cities at risk. So what we see here is a picture of a challenge that we want to avoid. We have to really try to manage this, and I'll explain how. Let me just move on. We must act now is the very clear message. We don't have time on our hands. I'm going to say that everything I'm going to follow with has to be put in place in the next 4 to 5 years. This isn't something that we can sit around and discuss in detail over the next 10 years. Next slide. At the University of Cambridge, I left government in 2017, and I've now formed the Centre for Climate Repair at Cambridge, and I believe climate repair is the right way we need to look at everything. Already the global climate has passed the point where we can simply sit back and say, if we reduce emissions, we'll be fine. Next slide. The basic principles of the Centre for Climate Repair are fourfold and are shown here. First of all, deep and rapid emissions reduction. Whatever we do, today we are putting into the atmosphere 40 billion tons of greenhouse gases expressed as carbon dioxide equivalent per annum. We need to bring that down to zero as soon as possible, but we also, too, need to create massive new greenhouse gas sinks. We need to restore the atmosphere from the present 500 parts per million to less than 350 parts per million going forward in time. Thirdly, we need to learn how to repair those bits of the climate system that have already passed the tipping point, and in particular, this means refreezing the poles, and I'm counting the Himalayas as one of the poles. Fourthly, we will work at the University of Cambridge to promote agile political and investment responses, and we'll work internationally, we're already doing this, with universities around the world to commit themselves to these principles of climate repair. The University of Stanford is already en route to doing this, and we're talking to major universities around the world to join us in this enormous big program of work. The next slide deals with political actions that have already taken place and are taking place. So first of all, national actions, regulations. Let me take regulations first and foremost. Carbon pricing has been based on a market principle so far in Europe. And I believe we've got to move on from that. In fact, the British government has introduced a floor price, so everyone knows it cannot fall below that price, whatever happens in the carbon markets in Europe. But I think we need a proper tax on carbon, and we need to announce that in 4 years' time, the tax will be, let's say, £50 a ton of carbon dioxide emitted. In another 4 years' time, 100. In another 4 years' time, 150. And that gives both messages that we need to tell the fossil fuel-based companies that there's a short timeline before there's a massive penalty on emitting the greenhouse gases that are currently taking place through their usage, but also through their sale. Carbon pricing, therefore, critically important, I think. Research, development, and demonstration I've referred to, green bonds and finance, Britain leading the way on that from the City of London. Foresight planning. We need to plan well into the future so that all of our investments in every country need to be investments that are fit for the future. We need to see that when we're investing in new housing, for example, we've got to anticipate those houses will be there in 100 years' time in a zero carbon world, in a post-fossil fuel world. We need all of these things. International cooperation with a hyphen between inter and national. These are relatively small groups of willing nations. I've already referred to Mission Innovation as an example of that. But this year, the European Union announced a $1 trillion green finance fund over the coming 10 years. And the incoming president of the United States has announced a $2 trillion financing fund for green finance going forward to help stimulate the recovery of the British economy. The global agreements are reached through the United Nations Framework Convention on Climate Change. Tremendously important to get every country involved, but also tremendously bureaucratic and slow. First agreement 2015, the discussions began in 1992. Just incredibly slow to reach a full agreement of all nations. And then we're still not delivering on what was agreed there, that 1.5 degree target. I take you fourthly to Mission Innovation 2. At their meeting last month, the ministers, it was of course a virtual meeting, the ministers of the 25 countries and the European Union within Mission Innovation agreed to finance another 5 years, but with an increased target to $45 billion a year. This will be confirmed on the first day of the COP26 at a meeting of the Mission Innovation heads of government outside the COP process, because this is just 25 of the countries. But I'm also very keen to see that there's a political arm to this fund. By the way, it's a fund of funds. Each country holds the funds itself, but agrees on expenditure for post-fossil fuel technology development. There's a lot of collaboration occurring on the major areas that are considered critically important. A political arm of 25 nations plus the European Union would be very powerful to be able to get decisions made quickly. For example, on carbon pricing, that group of countries representing something like 80% of the world's economy, it includes China and India, could make enormous progress very quickly in that sort of format. Let me take you to the next slide. I'm not going to take you through all the details of the greenhouse gas removal technologies, but our objective is to see if we can remove 30 to 40 billion tons of greenhouse gases annually. That is roughly what we're emitting globally today. We want to be able to remove that amount annually, but also to get emissions down to net zero. And if we do that, once we get emissions down to net zero, it would still take us about 40 years to achieve the target figure of 350 parts per million, 40 years or more. So it's a relatively slow process. And I've already shown you the risks associated with melting ice on land. So let me take you to the next slide. The Centre for Climate Repair in Cambridge, working with others around the world, are focusing on technological feasibility first and foremost of each of these new technologies, scalability, how much carbon dioxide and other greenhouse gas removal can we achieve with each of these technologies. We're not looking at any technologies that we think will not be capable of removing at least 1 billion tons each of carbon dioxide equivalent. Cost is also a factor. But let me also say, we want to see if we can develop solutions that are nature mimicking solutions. All of our technology effort is going to be to see if we can take examples from nature, and the forests are a very good example on land. Can we also, for example, create forests on the oceans? 72% of the world's surface are oceans that would also take up greenhouse gases, and where the challenge for land is such that it's going to be difficult to put as many trees as we'd like to put in to remove greenhouse gases into the landmass left. So the oceans is one of our target areas. We focus on potential adverse impacts, and we want to talk to the public representatives, political representatives on each of these technologies to take them along with us. We don't want a big outcry because any one of these technologies might have a negative impact. Next slide. This is my favorite. I come back to the oceans. Ocean iron fertilization. Now, this is a nature mimicking process. When the wind blows over the Sahara Desert, for example, and picks up small dust particles, those dust particles, the Sahara is a reddish color, as you know, the desert sand is reddish. That is iron in the sand. And iron is the missing nutrient in the ocean. So what happens when the wind blows over the Atlantic Ocean from the Sahara and then stops blowing? It powders the ocean surface with this iron-containing dust. And within 2 months, that whole area, which might be 10,000 or 100,000 square kilometers, becomes a green forest, a green ocean forest containing a large amount of plankton, in particular phytoplankton. And that phytoplankton is the initial foodstuff for fish. And so within a few months, you've got a massive stock of fish, billions of fish in that area. It restocks the ocean with fish. And before long, you get bigger fish coming along to eat the smaller fish. And you've got an entire ecosystem driven by the forest that's been created by that process. The only missing nutrient in most of our deep oceans is iron. And you only have to stimulate this with this powdering of the surface with iron. The net result is that carbonate is formed and deposits into the ocean crust. Now, we have to make sure that this is the majority result and that we don't see carbon dioxide re-emitting back into the atmosphere. We will be checking with detailed experiments at different parts of the ocean to see that this works well. If it works well, and if it's rolled out to scale, we believe that just covering 2 to 3% of the ocean surface in this way every year, we would always cover a different area of the deep ocean surface, would lead to removing roughly 30 billion tons of greenhouse gases a year. So this is a potentially promising technique, remembering that as well, we will restock the oceans with fish. We could return the oceans to the level of fish that were there 200, 300 years ago, which you can read about from all of those stories of the seafaring sailors that reported on the fish they were always spotting. Next slide. Solar radiation management. How do we refreeze the Arctic? One simple method, which is the method that we currently favor, is to see that the clouds that tend to gather over the Arctic Circle region, that the clouds are very bright white clouds, mimicking ice that would normally be covering the Arctic North Pole region in the Arctic summer. If you can reflect the sunlight away with cloud cover, with white cloud cover, then, of course, you can see that any ice formed during the North Pole winter remains during the North Pole summer. And so that's a major objective. And we have a brilliant marine engineer based up in Scotland, in Edinburgh, who has developed the technology for developing this. And again, this is a nature mimicking process. It's simply taking seawater, spraying it up above the clouds. And when this comes back down onto the clouds, the whitening occurs because of the very small salt particles contained in the seawater spray. So that is a method that we hope to raise money to test. And if we can find it works, of course, we'll roll it out. So these are the challenges that we might be able to do with marine cloud brightening, cooling cities, cooling farmlands, but in particular, aiming for refreezing the poles. The next slide, and I promise you I haven't got many more to come, is just to show you Salter's model for spraying salt water up into the upper atmosphere to cause the whitening of these clouds. If a cloud is dark, we can easily whiten it by this technique. We know this works, and this is Salter's mechanism of doing this without using any energy to pump the water up. And we're not installing energy. the energy is coming from the movement of the ocean itself. Next slide. And I've come to the end. What I do want to say is there is a way forward. We must not despair. There is a lot of reason for hope. And I think that globally, I sense a great movement to back what I'm saying here. Certainly, I'm getting tremendous responses from universities around the world, from political figures. But in particular, what is new is what is happening in the City of London, where the banks in the City of London fully recognize that what they need to do is look at investing in future technologies that are future-proof against the greenhouse gas evolution that has been happening. But we're also talking to them about working with us on managing the risks of climate change in the way I've just described. Thank you so much for listening.
Thank you very much, Sir David. That's fantastic. And we've got some questions to put to you from the audience. So obviously these days, or recently anyway, there has been action from communities. Greta Thunberg started this popular movement. Extinction Rebellion is very big in trying to provoke governments to take more action. So one question is, do you believe that Extinction Rebellion has a part to play in encouraging governments to act, and do you support their methods, Extinction Rebellion?
So let me answer you very directly in this way. Extinction Rebellion have been taken to court several times, and they wrote to me and asked me if I would act as a defense witness for their appearance in court in London. And I put forward a defense witness statement ahead of the court case. And I, of course, attended, ready to give my witness statement and to be subject to cross-examination by the opposition. But the judge simply said he had read all of the details. He had met the Extinction Rebellion members who were before the court, and he said he felt the prosecution had no case to make, and he threw their case out. It didn't even come to a discussion. So I'm simply saying, I think, and the judge himself said this, these are honorable people who are really trying to gain attention to what is a dramatic challenge to our future. And I do think that sometimes the measures of the kind that they're using to get attention are necessary. I also attended a meeting called by Extinction Rebellion in the run-up to the last election in one of our cities. And what was interesting there was they invited all of the candidates to the meeting, and I spoke first, and then they asked all of the candidates what they would do on climate change and how much of a priority it was for them. That was a meeting called by Extinction Rebellion, and every candidate was there. Let me say bar one, and I won't say which party was not represented. But I think the important thing is, I'm not a member of Extinction Rebellion. I wouldn't want to be a member, but I am happy to appear on their behalf. I don't believe that they are a violent organization. I don't think they have any intentionality in that direction. But rather like Greenpeace, they have learned how to get attention to themselves.
Okay, thank you very much. The next question talks about the high-speed railway, HS2. Bearing in mind the huge amount of concrete used in construction and the fact that doubling the speed of trains uses 4 times the amount of energy, should the UK be pursuing this project?
Well, this is a big political question. And of course, as a scientist, I shouldn't be engaging in political questions, but you phrased it in a way that doesn't leave me much of a way out. So you're raising it in a very good way. The reason, of course, that we're looking at fast rail in Britain is because of the success of fast rail in Europe as a means of public transport to move people swiftly around Europe. And anyone who's traveled on the European fast rail system will know the benefits. It's massively challenging to air travel. And of course, that's a very big plus when it comes to fast rail travel. Now, of course, Britain is rather smaller than Europe. And so that argument is not quite as strong as it would be in Europe. But I do think there is another argument that rather worries me. I am very keen to see that we move towards a much fairer society with a better distribution of wealth. And one of the challenges Britain faces is that so much wealth resides in the south, so much wealth resides around London. I believe that fast, easy, ground-based travel, and I have to say without emissions of greenhouse gases when all of the electricity is produced by renewable sources, means that we would be able to really get the whole country together in a way that perhaps it isn't now. So I'm not as clear-cut as this question would imply. Yes, a lot of concrete will be poured, and yes, a lot of steel will be used, and both of those cause a lot of emissions. One of the big targets of Mission Innovation is to replace the emissions from both of those technologies. Steel, for example, could be produced with hydrogen. We shouldn't have to be able to. We shouldn't have to use fossil fuels in steel production. Replacing concrete, that is also a target for Mission Innovation. So I'm, as you may see, not entirely ambivalent. I tend to favour fast rail.
Okay, thank you very much. The next one is about the technologies to repair the climate. So when do you think that the new technologies might be available?
That's a critically important question, which was really posed by my whole lecture. We've already gone past the tipping points on a number of major issues challenging us into the future. So I think as soon as possible, but I don't want to hasten the process of the careful range of studies that have to be made to see that there are no negative impacts at employing any of these technologies at scale. And I think that means we have to be able to raise the funds quickly to do these experiments. And I'm saying quickly, I want to raise all the money for this within a year. And we need to deliver the results of these analyses within 3 to 4 years so that we can scale up the technologies. So, for example, on the technology I've said I personally favor, which is creating green forests on the ocean surface, restocking the ocean with fish, but at the same time taking up carbon dioxide from the atmosphere. We are working with 4 other universities and research institutions to see that at least 3 different experiments are conducted simultaneously, and we want those done as quickly as we can. I've been out to Hawaii. I've been over there, ocean-going experimental vessel, and it has all of the equipment we need to conduct these experiments. All that we need now is to raise the money.
Yeah, and that could be a slight problem. There's a calculation that to just replace the electricity generated by fossil fuels with clean energy would cost about $100 trillion, which requires an investment of $1 billion a day over the next 30 years. So, I mean, we're talking huge amounts of money, aren't we?
But can I just say, I'm not going to disagree with the numbers you've given, but by 2025, for electricity production globally, the majority will be from renewable energy because it's the most efficient market-facing technology in terms of pound spent per kilowatt hour produced. So that investment will be needed. Coal-fired power stations have a limited lifetime. Many coal-fired power stations in the world are coming to the end of their lifetime, and they can be and must be replaced by renewable energy. That's not going to cost more money. It's going to cost less per kilowatt hour of installation. So I do not see that as a cost of the transition. I see all the benefits of that transition. And let me just emphasize, it's not only dealing with these massive climate change challenges, but just look at the number of children dying in Britain today from the level of pollution in our atmosphere. We're looking at something like 8,000 a year in Britain. So the benefits from moving in this direction are in every way because it's much cleaner. You're using local energy sources. It's the right way to go.
Okay, thank you. This week, Rolls-Royce made an announcement about producing small nuclear energy reactors to generate electricity. So the question is, do you see these small reactors as having any role in energy production versus focusing on green technology?
Yes, I do. So some years ago, I'm going back to the year 2003, I was described in some of the papers as a nuclear energy salesman, and that was by somebody who was critical of nuclear energy. That was when I was working on a energy white paper for Tony Blair, and it seemed to me we could never manage to get to net zero emissions, let alone 80% reduction in emissions without nuclear energy, because, of course, renewable energy, it tends to be intermittent. The sun doesn't shine at night, and the wind doesn't always blow. If you have a nice, stable energy supply, you overwhelm that. Now, as you know, the country was planning to build large new nuclear energy generators, 1.6 gigawatts a time, which is the way the world has been going. Small nuclear reactors at 50 megawatts a time provide a massive advantage over these large reactors, first of all, in terms of safety, but secondly, in terms of cost. You can build the reactor essentially in a factory, deliver it, and construct it on site. It's built very quickly on site. You're producing electricity shortly after you've paid the money, and you're collecting revenue from the kilowatt hours you're selling. So it is a much more efficient way to operate. If you want 1.6 gigawatts, just keep adding modules, 50 megawatts at a time, and you'll build up to that in 4 or 5 years. And you can deliver it in the same timeline it would take to deliver 1.6 gigawatts, but you would get no electricity from the 1.6 gigawatts machine over that period of time. And I'm afraid in the West, the average time for new nuclear large-scale energy production is 7-8 years. I mean, in China, it's 4 years, but that's a very long time to wait before you get any money back from your investment.
Okay, thank you. Just a few more questions because we're coming towards the end of the time we have. So a question from a university lecturer is as well as developing new technologies, what role can universities play in raising awareness and changing behaviour? I guess she means behaviour of the general public.
So this is a very important question because I tended to dwell heavily on technology in my lecture, but here in Cambridge, the Centre for Climate Repair has a total of 42 senior academics who are associates of the centre. These are people who are university professors and readers. And while many of them are from physics, chemistry, engineering, technology disciplines, the majority are actually from social sciences, from economics, from behavioral sciences. And so I'm very happy to tell you that we are focusing heavily on both the question of public acceptance of the need for these new technologies, but also on public transition into thinking about clean energy moving forward in time. Governments know that they need to be elected in democracies by members of the public. The public has a very, very strong role to play in pushing governments in that direction. So, no, I think what you've just said, critically important going forward.
So, I mean, do you think that politicians who say we're going to put tax on carbon, we're going to devote a lot of money to the future rather than to solving current problems, are they going to actually win elections rather than governments who say, you know, it's all a myth and we'll spend the money on helping our citizens today?
So if you take the gist of my lecture, where I'm dwelling not so much on 100 years' time or even 500 years' time, I'm dwelling on 50 years' time and the challenges faced with us, 30 years' time, 2050. That's not a long way away, but actually the challenges are with us today. If we look at the state of Australia, the forests burning, if we look at the state of California, you only have to look around the world and can see the challenges year on year today. We need an investment to see that we have a safer future in the immediate future, let alone for our children and grandchildren. So I think we must take a long view, but I think the question of carbon pricing, I'm trying to express it in a way that everyone would understand on that longer view, the midterm view, 30 years. If you say, no, carbon price stays where it is with the market pricing in Europe today, but in 4 years' time, we're going to have to increase it to a baseline figure of £50 a tonne, and then that will be seen as a mechanism for speeding up the transition to the new clean energy technologies coming through, to all of the post-fossil fuel technologies. That's got to be, we have to take the public with us, in other words.
Absolutely. So this is the last question. How do we, in the words of one question, how do we harness the hearts and minds of electorates and governments who are climate change deniers or only interested in short-term issues? How do we harness their hearts and minds to commit to doing something about climate change?
I point to this massive success of the offshore wind industry in Britain. And let me just say a word about that, because the offshore wind industry is taking over from the previous offshore oil and gas industry, and in a very real sense. So I'm going to take you back many, many years when I was invited up to Scotland to talk to the people working in the offshore wind industry, a lot of them marine engineers working out there on how do you stabilize the systems for extracting oil and gas from the North Sea. And of course, the capability they have is exactly the capability we needed for the offshore wind industry. So as these people were losing their jobs in the offshore wind industry, in the offshore oil and gas industry, they were taken on by the wind industry. And that was massive. So the offshore wind industry is a very big employer of these talents. It's a very big employer, full stop, around the whole world. If you install wind turbines, if you install solar panels, these must be maintained. There's a lot of work associated with them. I work, for example, in advising the government of Rwanda. I'm a senior strategy advisor to the government. And that government, following a big report I helped them to produce in 2010, committed themselves to a green future. Now, their economy is growing at 8% a year and has been for 20 years. It's a very rapid growth period. So everything they're doing is basically de novo. They're beginning from scratch. So they can invest in green futures. So instead of importing oil to burn to make electricity, which they were doing, you say up solar panels, you put Rwandans to work on the solar panels, you put them to work creating big businesses to maintain the solar panels, to replace when they stop working, etc. And it's actually contributing massively to their economic growth. So what you see is the very opposite of the premise on which your question is based. But the question is really important because we need to get that message across to the public.
Okay, well, that's a very positive note to end on, I think. So thank you very much. I would now like to call on the Dean of Coventry Cathedral, Dean John Whitcomb, to reflect on what we've heard today. But just quickly, can I thank the Rising team, especially Richard Dixon, for the hard work in organising the video communications and all that. We very much appreciate what Rising has done for us. So can I call on Dean John Whitcomb to make his closing remarks, please?
Thank you very much, Philip. Thank you, Sir David. What an extraordinarily riveting, gripping lecture. And sorry not to have you here in person, but that's been a tour de force. A number of reflections, and if I may, just to kind of summarise some of the things which I heard you say, both for my own benefit and to kind of, as it were, lodge them in there, and for the benefit of people that have listened to it. I'd love to have probably asked you a little bit of a question about how you and David Attenborough can kind of exert a sort of pincer movement, really, on the national psyche. Like a lot of other people, I've recently watched his kind of testimonial on Netflix, which is, I think, similar to, in some ways, to what you've just said, which hits us pretty hard with some devastating stuff in its early stages, but then actually somehow, against all the odds, manages to turn that into a message of hope and possibility. So thank you for not leaving us, as it were, down one of those awful methane explosion holes, which were so extraordinary. Really, really grateful for that. So you started by talking about how we as humanity need to learn to live both with and as part of nature, which is such a gripping image, especially in a place like Coventry, where we talk about peace and reconciliation. We talk about trying to live in wholesome relationships with one another, and increasingly, just as this lecture has, the subject of this lecture has indicated, really, we've come to see responding appropriately to the challenge of the climate and the planet as part and parcel of that commitment. So this is part of taking that forward. As you moved us on, I think you've managed to draw on an extraordinary kind of mixture of science and political nous and kind of business entrepreneurship, which I think is one of the things that I found most compelling. And so you talked about this being the greatest political and diplomatic challenge of the era, and then took us straight away into talking about how renewable energy and mission innovation is something that makes political and business and scientific sense, and to bring all of those things together, and then inspired us with the view of the Variolift airship. And I think you kind of just about convinced us. It all looks a little bit his dark materials, really, but I guess there's some. But anyway, we'll look forward to travelling on that in due course, and then into, of course, the polar regions, which I guess we've often seen mention of, but a really riveting inclusion of the permafrost and methane in that, which certainly I don't think I'd quite caught before. And then that sort of central motif slide that you had of "we must act now" in sort of big letters in the middle of the screen, just as something to take away. And then, of course, into the work that you're doing in Cambridge and that fourfold call for deep and rapid emission reduction, for creating those means of capturing the greenhouse gases, refreezing the poles, and then about creating agile political and investment responses. I didn't really believe that you could refreeze the poles, but then you gave us those images of seeding salt into clouds, and that was really exciting. And I think after the airship, your second favourite thing was about the oceans and that extraordinarily beautiful image of the sand blowing off the Sahara into the oceans and then kind of kick-starting a whole ecosystem. And I could see, I won't say Disney movies, but there was an imagined site behind that. As you, again, just helps us trying to think about how we can try and mimic nature, follow the natural processes in nature to sort of begin to put this right. This whole idea of this being the Anthropocene, I'm not sure I've got that word quite right, but that point where we uniquely have the ability to actually influence the natural process of the planet. And if we've got that ability and that power to try and do that in a way that actually follows the process of nature anyway, is enormously compelling. So all of those things, I think, have left us with a sense of possibility, not just disaster, which is, again, a very Coventry theme. We know about it looking as if our world has come to an end, but actually being able to honestly label that is one of the things which we feel we have the ability to do in Coventry as we talk about the ruins of the cathedral and some of the evidence that destruction is still around us in the city. But having labelled destruction honesty, then also to speak confidently about hope. And I guess just to come back to the sense, I suppose almost where I started, where that image of as it were you and the other Sir David Attenborough kind of doing that pincer movement, the possibility of an individual person playing a part and the conviction that actually each of us has a part to play at whatever age or stage of life or whatever our area of expertise. So I'm thrilled and enormously grateful, and thank you for leaving us with a sense of inspiration rather than a sense of despair at the end of what has been an immensely deep and worthwhile time with you. So David, thank you so much. We're really, really, really grateful.
Thank you.
Thank you.
Okay, thank you very much. And can I just say that the Rising Global Peace Forum has also sent Sir David a message thanking for his inspiration, and and the Lord Mayor too. And I think we all have a big debt to you for honouring us with your presence this year. And Rising would like to remind people that the Rising Global Peace Forum continues. So this is part of their programme this year, and it continues tomorrow at 9:30 with Dr. Hussam Zomlot, head of the Palestinian mission to the UK, and the joining instructions will be available on the Global Peace Forum Facebook page, and there will also be on our website, coventrycityofpeace.uk. If you go to the events page and look at the Rising Forum. Okay, so Lord Mayor, have you got a word to say at the end?
Just 36 years on from the Peace Lecture starting, now people surely must know it's one of the most worthwhile events in our calendar. Thank you so much, Sir David. And as a very small and minor politician, one thing I'd ask you to remember about politicians, and it's come home to me, I'm a mum, I'm a grandma, and as you were talking, I was thinking of the ages my grandchildren will be in 2050. I'm so glad we've got Greta Thunberg's around to hold our feet to the fire. I think we need it. Thank you so much, sir.
Okay, and with those inspiring words, I think we can close this annual lecture for 2020.